With the move away from the soldered side seams, metal box have had to invest in new technology for can manufacture. One method is the development of the two-piece container. Tin plate is first stamped into a cup, and then the sides, or wall of the cup, are ironed to increase the length of the sides. This is then trimmed to the appropriate can height, followed by decorating and flanging. This type of can is used extensively for beer and beverage, also for pet food and baby food products. However, this method of can manufacture is only suitable for extended production runs. Another technology is the introduction of seam welding. This system utilizes the existing downline equipment and lends itself to height and diameter changeovers and shorter production runs. This program is about this process. Seam welders used by Metal Box are made by the Swiss firm Soudronic AG. They manufacture a variety of machines to produce bodies running from small mixer drink cans up to 20-litre drums. The products packed in welded cans include all types of aerosol products, oil, paint, food, beverages and pet foods. When compared with the soldered seam, the welded seam has many advantages. It has a much stronger bond, being able to withstand internal pressures of up to 300 pounds per square inch. The body of the can will split before the weld. The welded seam needs only a narrow margin, giving much more decoration area and a more pleasing appearance to the can. There is a considerable saving in material on the blank size compared to the soldered can. There is only 0.5 mm overlap compared with 5 mm needed for hooks necessary for the lock seams on soldered cans. Just compare the difference between a soldered line and a welded line. Also, as a spin-off, the working environment around welded can lines is more pleasant and, more importantly, lead-free. The welders used by Metal Box in the United Kingdom packaging operations are SBW, used for making the larger cans, 4 and 7 pint beer cans, or A10, FBB, used for high volume production of the popular size cans. The output of this machine can be as high as 500 cans per minute, depending on can size. Scorers can also be fitted to the machine to give double the output on small can heights. Sequence of operation. Square blanks are placed into the top of a hopper, gravity fed down to where blanks are extracted singly by a suction head, and fed forward by reciprocating fingers to a flexing unit. On the way to the flexing unit, a sensor will detect any double blanks and operate a deflector, which will divert the blanks into a reject tray. At the flexor unit, the blanks pass between a series of flexing rolls and steels, breaking down the stresses in the plate, enabling the cylinder to be formed. The brake steel diverts the blank around the welding arm onto the catching bar. The unwelded cylinder is now formed. The cylinder changes direction by means of a pair of feed chains on the first drive unit, onto the Z-bar, which is mounted on the welding arm. The Z-bar controls the unwelded can by means of a spring-loaded guidance cage. The can is then forwarded down the Z-bar by a second set of feed chains, driven by the second drive unit gearbox. This gearbox has a variable drive, enabling the speed of the dog chains to match the speed of the welding rolls, which then takes over the transportation of the cylinder. When the leading end of the cylinder enters the welding roll, the dog chains are on the slowing down phase of their cycle, thus eliminating any damage to the trailing end of the cylinder. As the cylinder is travelling down the Z-bar, it leaves the guidance cage and enters the calibration unit. This unit controls the amount of overlap of the cylinder to be welded. Approximately 2 mm before the centre line of the welding rolls, the cylinder passes through a set of diabolo rolls. These rolls are set to give an overlap of between 0.4 mm to 0.5 mm. As an addition to customer requirements, the weld can be done in an inert gas to eliminate the oxidation by the welding process. This is done by bombarding the weld with nitrogen, and to direct the gas onto the weld, shrouding of the welding rolls is necessary. The welded cylinder is then transported by a magnetic overhead conveyor to the lacquering station, where lacquer is sprayed on the internal weld. This operation is more commonly known as side striping. This eliminates any interaction between the weld and the product that is packed into the can. The cylinder can also be side striped by means of a spray or a roller application on the external weld to protect the can from atmospheric conditions in accordance with customer requirements. From here, the cylinder enters a curing oven. In the oven, the lacquered part of the cylinder is heated to remove the solvents and to harden off the lacquer. From the curing oven, the can bodies follow the existing process as for the soldered can bodies. These are can parter, to separate the scored cylinders if two high cylinders are being manufactured. Flanger flanges the two ends of the cylinder. This is the first step to the double seaming process. Beader, to strengthen the can. Seamer, to place an end onto the cylinder. Tester, to check the can for leaks. We shall now look at the principles of resistance welding. Two electrodes, or two clamps, are incorporated in a circuit of low resistance, and the metals to be welded together are pressed between the electrodes or held in the clamps. The circuit is thus completed, and the electrical resistance at the overlap of the metals to be welded is higher in comparison with the rest of the circuit, so that if the current is heavy enough, the overlap of the metals is heated to a plastic state, necessary for the fusion to take place. Before explaining the resistance seam welding which is carried out by the Soudronic welders, it's necessary to first explain spot welding. In the spot welder, a pair of copper electrodes, air or pedal operated, are pressed together, with the metal to be welded sandwiched between them, and a local spot weld is formed at the point where the metals are clamped by the electrodes, the effect being similar to a rivet. The seam welder is similar in principle, except that instead of the two pointed electrodes, there are two edged rollers. The plates to be joined are passed between these, and whilst a slow travel takes place, the current is switched on and off at a suitable rate by a switching device. This results in a line of spot welds, the spacing of which is determined by the speed of movement and the current timing. The disadvantage of this method when welding tin plate is the tin is transferred to the electrodes, thus reducing the efficiency of the weld. The Soudronic system removes this contamination by introducing an intermediate wire electrode around the rolls, continuously presenting a clean surface for consistent weld quality. The round wire is fed from a drum or coil and is guided by a series of pulleys. It then goes between a pair of profiling rolls which flatten the wire to give a broader area of contact with the weld joint. From the profiling rolls, the wire goes to the top and bottom welding rolls, then onto a wire drive pulley, and finally into the disposal part of the system, where it is cut into short lengths by the cropper and then collected in a drum for recycling. By using this intermediate electrode and incorporating very precise electrical controls into their machines, Soudronic have designed welders which are capable of high-speed can manufacture at prices competitive with standard soldered side seams. In order to achieve the designed output of the machine, individual settings and material used must be within the laid down specifications.